Thanks, it's really nice to be here among musicians and other people. I have an office at the University of Oslo in a building that we share location with the Department of Musicology. And when I walk to my office, quite often I hear students playing the flutes, the piano, singing, etc. in the rooms that I pass on my way to my rather dull office. So I really appreciate that. I also feel like I'm like an old school lecturer standing here. I guess you all know what this is. It's a pyrite. What about the question here? What is time? Have you thought about that? I guess you all have, and the answer certainly depends on where you're starting from and your background, etc. And my answers to that question is related to geology, which is my profession, and which is also the topic of this lecture. So what do geologists mean when they talk about time, and what does time mean in geology? For me, this is time. Not only because of my son standing here, growing and aging year by year, but also the layers, because layers in geology, like these layers, are deposited, and deposition takes time. And by looking at these deposits, we can reconstruct time. In many cases, time is actually recorded roughly at 1 centimeter per 1,000 years, and that's slow. And also considering, that the hundreds of kilometers of deposits worldwide, there's immense record of time out there. We just need to learn how to read that record and reconstruct time. This is also time. This is trilobites. They disappeared 250 million years ago. They are old. They appeared on Earth about 550 million years ago. So they actually stayed on Earth for 200 million years, and they then disappeared. And the reason for that disappearance is what I research on at university. So I study mass extinctions and the causes of mass extinctions. Also looking at this, this is a picture I took last weekend, south of Oslo. It is there. You can touch it, you can look at it, and you can be fascinated by it. It's a record of time and previous life on Earth. This is also time. The formation of mountains takes a lot of time. Young mountain ranges are maybe 5 to 10 million years, but they may last for hundreds of millions of years. So when you look at the landscape, there's a code. The landscape is coded in time. So we can actually be able to read and interpret the landscape because the different varieties have their different origins and their different timescales. So this is a mountain range, Lyngen, just south of Tromsø. It's old. We actually don't know exactly what age it is, but it's likely about 50 million years old. And it's still there. It doesn't erode easily. It's persistent. We can also look at time as a sequence of events. One thing follow after the other. And this particular figure is a classic within, let's say, the history of geology and history of science. Because from sections like this from the UK, from England, the first geologists, about 200 years ago, kind of discovered time. They discovered the sequence of events and the deep abyss of time hidden in layers of sand, in mud, in fossils. So in this case, you see the folded layers. Those layers were folded after deposition on the seafloor, maybe a mountain range. And the mountain range was eroded to a plain, and there was gravel deposited on top, and then limestones on top of that again. So deep abyss of time in a simple sequence like this. Time is also, it's people, it's us, and we modify nature. And this is, of course, the topic of this lecture. What do we do to nature, and what is the meaning of it, and what is the context of people, our activities, and then how we actually think about time, and how we divide time into periods, eras, epochs, and so on. So this is the modified nature. So think about the concrete being buried on the beach and then becoming rock with time. So the question is, how can we make sense of all this? It's not easy. Geologists have been trying for 200 years and longer, of course, all the way back to the mid 1600s to try to decode what happened, to try to decode the meaning of it and the time aspect of it. We have made sense of it, and the following diagram makes an attempt to show that. So this is the International Chronostratigraphic Chart from 2014. It may look dry and dull, but this is the Earth divided in time, in sequences, and in periods and epochs. Have you heard about the Precambrian? Precambrian is old. It's before the trilobites. It's before about 550 million years ago. That's the start of the Cambrian. And everything before, which is the majority of time on Earth, is a Precambrian. So we divide time into the big aspects, the big eons, the Precambrian. We have the Phanerozoic after the Precambrian. We have eras, we have periods, we have epochs, and we have ages. It's a system that is built by looking at rocks, by looking at fossils, but also dating rocks. So you may wonder, what is our time called? It's not an easy question to answer in one way, because you have to understand the division of this complex diagram. But to make the story short, we live in the Cenozoic era. And the Cenozoic era started 65 million years ago, defined by a crisis. And a lot of these transitions are actually defined by crisis. If you look at this figure, it shows extinction periods plotted against millions of years ago. So when there is a high peak in this diagram, there was a big mass extinction. And the biggest of them all took place between the Permian and the Triassic. Up to 95% of life in the oceans disappeared, and a third on land. And also there's other extinction events that made the trilobites disappear, and of course also the dinosaurs disappear. And these crises are used to define time in this complicated diagram. We also live in the Quaternary period. I'll come back to that. And also you can see the latest epochs, the Pleistocene and the Holocene. So the Holocene is actually the time after the last ice age, and that used to be our epoch until the Anthropocene arrived. So we have the defining crisis. The question is then, is the appearance of man on Earth also a crisis that can be compared with all the other geological boundaries and crises that we know from Earth history? So we live in the Cenozoic, and actually that's our era, and that's defined by the impact that hit Mexico 65 million years ago, and then disturbed life on Earth. So it's that level that we talk about when we divide time. It's the big events that we actually can find in the geological record. And the dropouts from that particular that disaster we can find in Denmark is this black layer in the middle of the limestones and chalk. So that's what we can actually see. And from these layers, we can reconstruct what happened 65 million years ago. Okay, let's zoom in on the Quaternary period, which is the period that we're currently in. So the Quaternary can also be divided into these really complicated and finely tuned diagrams. So this is what geologists actually work with. And of course, for us here, it's really remote, but I have to show it to know actually what's behind the division of time. There's a lot of scientists that contribute to various aspects of this, studying rocks, dating rocks, etc. But it doesn't stop there. You can look at this diagram. It's a bit blurred. It's not meant to actually look at the details, but we do the same things. And we had the big picture, we zoom in, and we could also zoom in, on the last 3,000 years. And this is history. So we also have the same type of looking at history. It's periodizing of history and the big empires and so on. So we can do this at all levels, both natural and also cultural history. Okay, so the last 2.7 million years, we have had about 40 ice ages on Earth. 40 ice ages. The last ice age ended about 11,000 years ago, and that's the start of the Holocene. And Holocene has been, up to now, our time period. It's a stable period after the ice age, and it's actually defined by geochemical tracers in an ice core from Greenland. So it's really, really specific and detailed when it comes to analysis and understanding of the detailed geochemistry. So this is the level that we are talking about when we divide time. It has to be really precise. It has to be recognized by many different scientists and many different locations around the world. So from this ice core, we defined the start of the Holocene. And then the question is Holocene over? Are we in the Anthropocene? Okay, so the idea of the Anthropocene goes back to 2001 when the chemist Paul Crutzen suggested that we have to do something with the way that people are exploiting the Earth and altering the Earth's surface and atmosphere. So he suggested that if you give this man's dominance on Earth a name, it might be easier to grasp it. So he suggested that let's call it Anthropocene. So it was politically motivated. It's not formally accepted. So what I've been showing you so far is the details in the chemistry and the composition and the layers that we actually have to go through to determine boundaries. So it's not formally accepted yet, because what should we measure as the start of the Anthropocene? What can we go out and measure as a signal of us? And that's what the debate is about currently. But still, it's really widely used in both the scientific and the popular culture. If you look at this graph, it simply shows the number of scientific publications in a given science database using the name Anthropocene. So it's increasingly rapidly. You can see from 2001, and especially from 2010 and afterwards, it's a massive rise in usage of the term. So anyway, it's used, and in that sense it's also established as a scientific term. And of course, people discuss Anthropocene in various aspects. So it's really becoming a part of popular culture as well. However, Paul Crutzen suggested this in 2001, but still it's not entirely unique in the way that people have actually been thinking about this before, that we alter both the atmosphere but also the surface of the Earth, and that it actually deserves a specific name. So in the late 1800s, Antonio Stoppani suggested that we should call man's era on Earth the Anthropozoic era. Also somewhat later, Marnatsky said that maybe we should call it the Psychozoic era, the way that the people and the mind interferes with biology and also with the Earth. And during that period also, in the early 1900s, the term biosphere was established. We got the geosphere, and people also talked about the noosphere, which is this sphere in between nature and man. And also various scientists wrote about, for instance, this guy, Robert Sherlock, man as a geological agent, altering the surface of the Earth. So a lot of early ideas about this, but still it wasn't until 2001 that this kind of got established. And the reason for that is most likely the concern about global warming. So the question is then, who's who in the Anthropocene debates today? Still, Paul Crutzen is involved in scientific papers and so on, and also the geologist Jan Zalesevich is writing a lot about this topic. So these are two examples only of kind of key scientists working with the concept itself. There's a lot of also other types of people like German Swagerl, and also of course Bruno Latour, that kind of use this idea and also develops it in various directions. There are a few skeptics that do not believe that Anthropocene as a concept has any meaning or should be used at all. They want to get rid of this concept. When it comes to debates and public discourse about the Anthropocene, it's you have to look closer to actually find it. And for instance, in Norway, it's mostly the literature magazine Vagant, where you can actually read about these type of topics. And in other types of literature, you can't really find it. And also, even if you go to geologist conferences, people don't really talk about this concept that much. So that's how it is. So Saljasevic, he actually is leading what is called the Anthropocene Working Group, and is part of the International Commission on Stratigraphy, and they're actually there to evaluate the scientific basis for the Anthropocene. You know, how to measure it, where to measure it, what can we use to actually measure the start of Anthropocene. So this is very technical, but still they have a lot of power. And also, actually, Saljasevic and the others, and many others in this group are actually proactive. They want to establish the Anthropocene. So they're trying to establish it with scientific, on scientific terms. The question is, Anthropocene, is it the same as geology, or is it more? It's much more. It's a part of culture. Geology is simply a part of it. We can use what we know about geology to get insight into this interaction between man and the planet and the biology. This is just one example. It's a book compilation writing about a lot of these different aspects, both in between the different sciences, but also between sciences and culture. It's culture history. So it's really a rich literature on, let's say, these cross-disciplinary topics, and also how this concept, what the concept actually means, and how it interferes with culture. So are the geologists the new heroes? Of course, I would like to answer yes, definitely on that question. But as here, there are critics. For instance, this statement. And if you were to live in the Anthropocene, does that mean that we have our geologs, like the Age of Enlightenment had its philosophers? No, obviously not. Christian Bjørkdal in Vagant edition earlier this year. So definitely a lot of people want to get rid of this term and do not see geologists as the big heroes here. And of course we are not. It's just the geology itself that is the key here. Crescendo, explosion. So crescendo is kind of only music relevant term that I put into this talk. And the reason for that is some people believe that Anthropocene started as a crescendo, as a gradual increase towards where we are today, whereas others believe it's more like an explosion. It started more suddenly. So there's two different types of ways to think about Anthropocene and when it started. So for instance, this scientist, William Ruddiman, he's a proponent for that Anthropocene started way back in time with the agricultural revolution, let's say 8,000 years ago, and that people have kind of then interacted and become a part of a coupled nature man or people system from that time. Others believe that this doesn't hold water because the changes, you can't really measure it because the changes are so gradual. And it's also been said that if we grew into a state already 8,000 years ago where we interacted with nature, then we are a part of nature itself. Then we cannot be separated. And that, of course, some people interpret as we can continue as we do. We don't have to change anything because we're already a part of the natural system. We are nature. So few people actually think that this is a good idea, that we have to go back 8,000 years. The Anthropocene Working Group and most scientists believe that we have to go closer to the present day, where there's an explosion in the CO2 increase in the atmosphere. It's people, it's how we use the land surface and so on. And Salasevich and others earlier this year suggested that is the bomb, the Trinity bomb, from 16th of July 1945. That's the start of the Anthropocene. And why is that? Well, that's because in ice cores from Greenland, you can actually measure radioactive compounds from the bombs in the ice. So you have a specific marker that says that this is where it started. So this is probably a much better idea than going back way in thousands of years back in time. Okay, so what is actually changing during that Anthropocene? What are we doing to the planet? I will just show you a few examples, just to remind you what we are doing. Of course, the critical here is the population growth. We are so many people now. The current world population is a bit more than 7 billion. And it's of course constantly growing. We need space. It's the oil that we consume for energy, and total amount of carbon released by humans from the oil industry is about 350 billion tons of carbon in total. It interferes with the oceans. It changes the pH of the oceans, which also affects life in the oceans. We affect the nitrogen, phosphorus and lead cycles on Earth. We're changing it by, for instance, extracting nitrogen from the atmosphere when we make fertilizers, make them into solids and then going out in streams again and ending up in oceans. Animals are extinct because of what we do. And like this dodo bird, dronten in Norwegian, and also the professor here, Homer Dill, he's also kind of extinct as a professor type. We alter the surface of the Earth. This is the famous Bingham copper mine in the States. More than 50% of the land surface on Earth is modified terrain. We see examples here, New York, Manhattan. I want to remind you of a project, the Manhattan Project, that tried to reconstruct the geography and the history of Manhattan before people arrived. And they also have this Manhattan Project is to look into the future. What can we do in the future to actually do something about it, to get more sustained development in big cities like this? So the last few minutes, it's about the future. What does this all mean? What is the Anthropocene really? So it's interaction with nature, but what does it actually mean? What does it mean that we are like a geological agent that can compete with almost even a meteorite when it comes to leaving a trace in sediments? What does it mean? This is one example. The anthropocentric understanding of history is incompatible with the Anthropocene thesis, where the key element is precisely the integration of history and nature. So the problem here is that when you put ourselves in the center, the anthropocentric view, that's problematic because it could be deterministic. Whereas this guy said, also a debate from Vagant, the key element is the integration of history and nature. And all of this is it's not easy to grasp what it actually means. And this is where we are at the moment. There's a lot of ideas out there, but few people have actually contemplated and studied what it actually means for us, both as a concept, but also as a consequence looking into the future. So the problem here is then integration versus dominance. Are we integrated with nature, or are we dominating it? And where is this leading to? Of course, we like to think that we have free will and that the future is not deterministic. All people, all scientists try to avoid deterministic views. We like to think that we can that nothing is governed by fate, or that we know where we are heading. So these two things, integration versus dominance, deterministic versus non-deterministic views, is really the key. Okay, this is a few bullets summing up some of the at least the geological aspects and also some of the other aspects with Anthropocene, is actually the only period defined by the activities of a species. All the other divisions of time are not driven by species, but by the planet itself or by processes from the space, like impacts. Another thing with Anthropocene, we do not know the outcome, and it doesn't have an ending. And what I think is maybe the most important of this is that it really opens up fields between the sciences, the arts. I started to collaborate actually with humanistic scientists at university about Anthropocene. So it's really one of the few concepts that all the disciplines actually find interesting and also can actually contribute to. And I also would say that to you, I guess many musicians here, is that we need people like you also to explore what does this really mean. So it's a new and, I would say, unexplored relationship to nature and deep time also. So as a geologist, so I'm trying to communicate the role of geology, of understanding the history of the earth in all this, but it's very difficult because we are just in the beginning of this let's say, whole journey. Thank you.